I hope everybody had a great summer. Today we are gonna today we're gonna be going over data structures, specifically singly linked list, which is the first data structures we'll learn so far. It is the easiest data structure, and hopefully by the end of this video you will also find it the easiest data structure. Okay, so let's head right into it. We're gonna go with the very basics, which is an array. What is an array? An array, you can think about it as a list of types of data, whether it's a string, an integer, a character. So here we have a string. Now, what is the issue with an array, and why do we even need a singly linked list? Now, let's assume this little box here is your realm. Let's make this a little thinner. In here, you'll have your 1, and you'll have your 2, you'll have your 3, you'll have your 4. And the problem with an array is when you store an array like this, what happens in the storage management in the computer, like the actual hardware, is we'll go in the RAM, find 4 slots that are one next to the other that is free, then put the array in there. Okay, so here let's say you have like a photo or words open and your other things that use up the RAM. So we'll find something that's free slots open one next to the other, and it has to be one next to the other. So if I were to want to add a 5th index here, what would happen is your computer would copy, will take this new array, the 5, or will delete this one, or will take this one and go find another 5 slots open one next to the other and then put them in. So we'll have to first copy the first array, add the 5th to it, then go find 5 consecutive empty spaces one beside the other, then store it in there. And that's why it's very inefficient to change the size of an array. But it's very fast to go in an index. So when you go, let's say my array's name is array, and I go index, let's do like 2. The reason the computer does it very fast is because it has the address of the first one. Let's say the address of this is 01 and this is 02 and so on. Now, when it wants to find the second index, which is 0, 1, 2, it'll right away know if my first one is address 1, then my third index, which is technically second index, has to be 03. So we'll go directly to the address and retrieve it, which is why it's very fast. Now, how does a linked list solve this issue? So what we'll have is a single linked list, and inside, obviously a list won't have this bracket, we just put it to clarify that it's like a list. But the way it works is you'll create a node, and a node is an object. You can think of an object as a box with 2 variables inside. One is data, and the second is a pointer. Now, if you haven't done C++, you wouldn't know what a pointer is, so just think about it as a second variable called next. Okay, so we know a node has a data variable and a next variable. Okay, now in the list you'll have nodes, and each node will point to the one in front of it, and this is specifically for the singly linked lists. The double list points behind and in front, but the single will only point forward. So let's say the data here is the integer 5, and it will point to the one after it. Now, if there is nothing after it, this will be null. So next variable will actually hold the value null, which is nothing. Now, if there is something after it, then it will just point to that something. Let's say this is like 10. And this one will now point to null. Now, if I want the second node, which in this case is this one, how can I get it? Now, obviously, unlike the array up here, nothing is holding the address of any of the nodes, so yet I wouldn't be able to, because I don't even know where they are. And Java has a garbage collection that if you can't access any variable in your code, then it's going to go straight to the garbage. So since we can't access it, even though we just created it, it's in the garbage. So what do? We create a variable called a head, and this variable will always hold the first node. Okay, it will always hold the first node. Now, if I want to get the second node, all I have to do is use the head, and remember, the next will hold the next node. So I could do the head, which is the first node, dot next, dot next, and this will give me the second node. Alright, so it's really that simple. Then I can even do dot next, which will give me the second node's next node, which in this case is a null. Okay, so this is a quick explanation. Now, why is this better than an array? Because if I want to remove let's say this node, so let's remove all this gibberish. So if I want to remove the 10th node, or the second node, the 10th data, then I can just make this pointer null. And now my linked list just shrunk in size to only one node. And if I want to add another node, I just create a node, let's say that holds 12, has a pointer, right? Now this will pointer to null at the beginning because there's nothing. We only know the data. We don't know what it's going to point to when you first create it. Now what I will do is just have 10 point to 12. Now I just increased my list to 3 nodes. Right? I just increased my list to 3 nodes without having to copy anything. And that's why a linked list is a lot faster than just a normal array when the sizes change very often. And that is basically the basics. So now if we sum up everything, we'll go here and we'll say that a node has a data variable and a next variable that holds the next node. Actually, let's since it's like that, there you go, that holds the next node. Okay, and a list is a list has 2 variables, a head which holds the first node, and a size which holds the size of the list. Now, do you need this do you need a variable size that holds the size of the list? No, like not specifically. Now, it doesn't make things a lot easier and a lot more efficient. Yes. So technically, like, you need it, but it's not mandatory. Like, your list won't break if you don't have size. There are other ways you can implement a list without size, but for this case, just keep in mind that you need the size. Okay, so now we're gonna go to code. I am not using VS Code or IntelliJ, so don't worry about what the text editor. Just worry about what I'm typing. Okay, so now as you can see, I have a node.java and I have a singly list.java. 2 files, that's what you'll need, and you'll need them both within the same directory, I believe, on IntelliJ. Yeah, in most Java environments, you'll need them both in the same directory. Okay, so first we'll do the node. Why do we first do the node? Because you can't have a list without nodes, but you can create a single node without having a list, right? So that's why we first start with the node, and we want it a public class node. Now, what type of node is this? It can be an integer, right? Or, in our case, we're going to keep it as e. What e means is it can be any type of data, but any type of object data. So you can't have e as an int. So there's a difference between object data and Java data, let's say. Java data is like int. You see it turns green. You have boolean, you have character, we said integer, you have double, float, character we already covered. But you see string is white, because string is actually an object of characters. So string is like a collection of characters, but it's not an actual data type. It's an actual object. So you can't, since we put e up here, you can't make node an int type. It has to be a int type. So this is, again, just a number, but it's an object. It's not a data type, but it's an int, an integer object for int type data. I hope that explains it better. So now we're just gonna follow our writing on the right and just do exactly what we just explained. Node has a data variable, so let's start a data variable. The data variable holds data. What type of data? just like up here we specify that's going to be any type of data. Because, let's say a person wants to store a string or wants to store an integer. You don't want to specify that. We want to keep it dynamic. Now, you can specify it if you want your list to be strictly an integer or strictly a string. But in our case, we're going to keep it dynamic. So we're going to say e-type data. So any type of data they can store in here. And the next thing is going to be our next variable, the next variable. But this one is not an e-next. You can't just store 5 in this next. This only stores the next node, so it's going to be a node type variable of any type data, and it's going to be next. Right? If you want to make a variable that holds a class, all you got to make it, the data type is the same as the class name, really. So not much stress there. Now, if these, keep in mind, if these were, oops, what did I just do? If these right here were, oh my god, if these were right here private, then you'll have to have getters and setters. But in my case, I'm going to keep them not private because I'm going to teach you the very basics. I feel like getters and setters we've already covered. It's just basic methods that get you the variable data and they set the variable data. So I'm not going to use them in my case, but you can definitely implement them just by making these private and, yeah, both of them private. Okay. So now, when you create a class, you need something like, you can think about like a contractor when you build a house. Somebody to actually do the building for you. And this is called a constructor, which constructs the class, right? Now, how do you create a constructor? You just make it public, because obviously the person constructing is not within the class, it's outside the class. Okay, so it's going to be public, and you're going to make it the same name as the class, and you're going to pass it the person who's creating it, the node, what do they want to create it? Now, if you don't pass anything, you'd make data null, and you'd make next null. But then why would you ever make a node that's empty? So this is kind of pointless, right? So we're going to make node take in a data type. So it's going to be any type of data type because we don't know what the person is going to store in there. So we're going to make it any type of data. And here we are going to make the class data equal the data in the parameter. But just like you, the computer is also confused. How do you know which one of these two datas, which one is this and which one is this? Who's equaling who? You don't really know that, and the computer doesn't either. There is a keyword called this. When you say this.data, you are telling the computer that I'm specifically referring the class's variable. I'm not referring the parameter variable or the arguments variable. I'm specifically referring to the class's data variable. And the other data is whatever else there is that is not the classes. And in this case would be the argument. Now another way you could do it is make this value. Let's say value 1. I don't know why it's value 1 actually. Let's remove it. And we're going to make this value. You see now here, if I don't have this keyword, it's fine because the computer is not going to be confused. It knows exactly what's going on because they're two different names. But it's an industry convention or whatever, industry standard is just having it the same name so you know who equals who. But just make sure you have this dot, your variable. And that's about it really for data. We just, for node. We create the node and we create the constructor that will create the node. Okay? So now we're going to save this and we're going to head into our singly linked list. Again, you want to start the class singly linked list. Now the list is not going to be, you can specify here like a string, but like we said, we want to keep it dynamic. They can create a list of any type. Okay, so back to here, what does a list do? A list holds the first node and it holds the size of the list itself. So we're going to have a node type head because it holds a node, so it has to be a node type data. And we're going to have an int size because it holds the size as an integer. Now, just like the node, you do need a constructor to, construct your list. And when somebody first, see earlier, we didn't have a default constructor for the node because there's no point of having null data and null next. Why would you create just an empty node? But for a list, when you first initialize it, you can initialize an empty list, then fill it out later. So that's why we're going to have a singly, so we're going to have the same name as the class, remember? And then we're not going to pass it anything because you can create it empty. And so creating it empty, we're just going to have this dot head. Remember, I'm referring to the class's head variable equals null because there's no nodes when you first create it, and size equals 0 because there's obviously no nodes, so size is 0. Now that this is done, the next one we're going to head right into is public void add. And I'll explain what I am doing. So now we're going to create a function that will add a node to our empty list. Okay, so how does this work? When someone creates a list, this is how you'll create a list. You'll do singly linked list, then you'll specify what type of list do you want. Let's say I want an integer type list. Then I'm going to specify the name of my list. Let's say OnlyFans. And then I'm going to create the new list, which is singly linked list. This is me creating just the instance. And this is how you initialize an empty list. Now, if I want to add a node, I'll say OnlyFans.add. And then in the bracket is where I pass the data I want to be stored in the new node. So you see here, this data is the data I'll be passing when I create or when I add a new node. Okay? So just keep that in mind. You'll call this function, you'll pass it some data, in this case an integer, so I'll pass it a 5. Oops. I'll pass it a 5. So now this variable will hold the 5 I'm passing when I call this function. And now you can code on how do I make the code add a new node to the list. Let me close the bracket. What happened? Hello? Okay. Now I'm gonna go here and do a quick explanation of how to add something to a list. Okay, so we're gonna have a quick list here. Let's say the first condition, let's say when you have an empty list. You have nothing, you have the head, which usually is supposed to hold the first node. Now it just points to null. It doesn't hold anything, right? So we can have this actually. Should I keep it as the head? You know what? Just for easeability of reading for you guys, I'm gonna name it first node. So this is also gonna be first node. Oops. Okay. So now, right when you first create it, the first node is null. There's no first node. Okay. So now I'm gonna also delete this and make it first node. First node is null. Horrible handwriting, I know. But let's say you want to create a new node. You want to add a new node that holds the integer 5. So we're going to create a new node that holds the integer 5. When you first create it, it points to null. Now, why does it point to null when you first create it? And that is because, as you can see here, when you pass it the data, where you pass it 5, the next will always be initialized as null. That's the way we wrote it. Okay? Okay. So, now that this is null, we want it to be added to the list. Because right now we created the object, but as soon as we create another object, like how do we keep track of who connects to who? That's why now the first node has to be pointing to the new node. And now you'll have a list of 5 that points to null, right? Now you have a list of one node. Okay? And so that's what we're going to do here. We're going to create, first, create the node, remember? We said down here, we said first, create the node. So now we're going to create the node. We're going to say a node type E. We don't know the type, remember? So that's why it's always type E. And then we're going to create a new node. This is the new node we're creating. Equals new, remember we're creating an instance of that node, of the node class. So then we pass it the value. And see, if we see what's going on here, then node, okay, here when I tell this variable, you're going to be of type node. You're going to be of an object from the class node. Then I use the keyword new because I'm creating a new instance of this class up here. Then I call the constructor that we wrote up here and then I'm going to pass it 5. This 5 becomes this data variable, which then the constructor sets it to this data variable, and the next stays as null. So now that we created that, okay, now what we want, like we said, we want the first node to become the new node. So we're going to say first, we're going to say this dot first node equals new node. See, now I just set the first node, this one, I just set the first node to the new node we just created because the list is empty. And so now we do have to tell the code if the size is 0, right? That means the list is empty. Then create a new node and whoops, there you go, and make the first node this new node because there's no other nodes. Okay, so this is what we end up with after adding a new node to an empty. Now, the second edge case, which is adding it to a non-empty. So let's say here I have 5, it points somewhere, then I have a 2, it points somewhere, then I have a 3, and it points to null. Okay. So now, what if I want to add one? When you add one, usually you add it to the last. Like, you're not going to just add it in the middle for no reason. You're not going to add it in the beginning. Usually you just add it to the last. Okay? So how do I add it to the last? Remember, we said, if you want to add a node, let's say I want to add a node 10, add it to the list. All I have to do is make this point to it, right? And then now, you just added one to the list. This will go away. And now this is what it looks like. This will point to null. And this is what it looks like, right? We just added one to the list. So how do I accomplish this? Obviously, the only node I actually have access to is the first one. That's the only one I have access to. So what I can do is, how do I know I'm at the last node? I mean, I can go from this node to this node because it points, right? But how do I know I'm at the last one? As you can see from this list, the only difference between any node and the last node is the last node is pointing to null. So if my node points to null, therefore, I'm at the last node, right? So what we're going to do here is do just that. So first thing, let's, hold up, let me fix this because it's bothering me. There you go. That looks better. Okay, now I'm going to say while. See, if first what you want to do, you want to have a temporary variable that holds your position, okay? So I'm going to have a node, e, and I'll talk about on why we're doing this. Current node equals first node. So my current node is always, I start at the first one. And then I'm going to say while the current node does not equal null, right? Keep going, do something. And I'll tell you guys what to do. Why did I make a current node? Because, let's say first you start at the first node, and you check, is it pointing to another node, or is it pointing to null? Then you're going to be like, well, I'm not pointing to null, therefore you're going to go to the second node. But if you go to the second node, and you change your first node variable, you will lose the first node. You can't go back to it. Right, so you can't change your first node. That's why I created like a temporary variable that tells me my current node. So now when I move my current node to the next node, I don't lose all the other nodes because my first node still holds the first node. Right? As soon as you change this to anything, like if I change this to null, I lose all the nodes. Or if I change this to the second node, then I lose the first node. So I always have to keep the first node holding the first node, unless I purposely want to change it to something else. Okay? So let me add the open bracket here. Okay, so now what I want to do is if the current node dot next, right? If the current node dot next, so what I'm saying, if the current node doesn't point to anything, so I'm saying if the current node does not equal null, which means the current node is pointing to something, right? Current node is not equal null. Sorry, I messed that up. I was reading the not. Current node does not equal null. That means I'm not at the last one. So current node equals current node dot next. Now why do I do that? What I'm saying is, here let's erase this. First I am here, right? Current node. Then I'm gonna be like, is the next value of that current node, is it equal to null? Or is it not equal to null? So my while loop says does not equal to null. Therefore, is the next does not equal to null? That's true. That means do whatever inside the while loop. Therefore, current node, right? This is my current node. Current node equals the next, current node dot next, which means now this points to whatever this arrow is pointing to, which is the second one. Then what I'm saying, okay, while now current node dot next does not equal null. It's true, it doesn't equal null. Therefore, go to the next node again. Go to the next one. Now, current node dot next does not equal null. That's false because it is null. Therefore, it exits. Okay? So that's what's happening here. So once it exits, now we know we're at the last node. All we have to do is, right now the current node is the last node. We achieved that. We want to make this point to the new node. And then we gotta increment the size. And that's about it. And here for the if, we also gotta increment the size and return, because if size is 0, we create a new node, we make the first node the new node, we increment the size and we return. We don't want this to run, that's why we return early, because we already added it. Okay? And that's about it for adding a node. Now public void, so we're gonna remove a node actually. So let's go down. Let's go down here as well. Now, in removing, you can also have it void, right? But according to Rapos, he wanted you to return the data of the removed node. So the node you're going to take out, return the data that it's holding. Okay? So that's why we return E, because obviously we don't know what data it's holding, what type of data. But we know we're returning something. We're not returning nothing. We're returning something. That's why it's E. Okay? And what we're going to take, you can either take data and compare, let's say I have nodes 1, 2, 3, 4, 5, and I want to remove the node with the data 5. I can pass data, and you can compare each node with the data inside it. Does it equal 5? And remove this one. But Rapos wanted by index. So I'll say remove the third node, remove the fourth node. I don't tell you what data is inside. I just want you, I know exactly which node I want to remove. Okay? So now that we got the setup right, let's do some visualization. So if I have a list of only, well, first, if I have a list of nothing, what do I gotta do? I can't remove nothing, so let's code that out. First, if size equals 0, right, return null. Now you can't just do return because you're supposed to return something. That's why we return null. Null is something. Okay? So we return null because there's nothing to do. There's nothing to remove. Now what if the person passes me an index that is negative? Right? That is also an issue. So we say if index is less than 0, also return null because you can't do that. Alright? Now let's come back here. And now what about if I have this, let's say this is one node, and this is pointing to another node, and this is pointing to a third node, and so on, and this is null. If you look at the size of this, 1, 2, 3, so size equals 3. But what about index? Indices start from 0, and then they go 0, 1, 2. So if I pass the computer an index 3, which is either equal to the size, or if it's more than, so if it's, here, actually I'll write it in mathematical terms. if the index is more than or equal to the size, then I also can't do anything. Because if it's more than the size, I can't remove something that's not there. And if it's equal to the size, that means it's also something that's not there, because indices are 1 less than the size. Because remember, the size is 3. What you see, the max index is 2. Because indices start from 0. Okay? So that's the second edge case, is that if the index is more than or equal to size, then also don't do anything. Alright? So now that we handle all these, what's the next step? Now we're going to do some more visualizations. Let's get rid of all this gibberish things and go back. Okay, so now we're going to have a list of a couple nodes. And then you have, let's say, node 2, node 3, node 4, and node 5. Okay, so now what if I want to remove the first one? The first node. How do I remove the first node? So remember, I have a variable called first node. There's one way I can remove it. I can just do first node equals null. This will remove the first node, but then I will lose everything else, right? So what I need to do, I need to make the first node the second one. So I need the first node to become the second one, then remove it, because then the second becomes the first node, right? So how do I accomplish this? I can't just change this first. First, I have to get a hold of my second node through my first node. So here's what I can do. If they're trying to remove, so if index 0, aka remove the first node, what do you got to do? Let's get the second node then. So what we'll do is node e second node equals first node dot next, right? That's how I can get my second node. Then what I'll say is first node equals second node. Yeah, actually, whoops, second node. There you go. And I just did that. But don't forget that you have to do size minus minus. And then return. So you see now, I removed it. Which we just did exactly what we said we did. Now there's one more way you could do this, which is the more efficient way, is you can just first node equals first node dot next. That is also an efficient way where you can get rid of that, get rid of that line, but we'll keep it here for readability sake. Okay. Whoops. There you go. Okay. So now that we're handling that case, now what about all the other nodes? What if I'm trying to remove a node from the middle? Okay. So now let's do that. What if I am trying to remove a node right from the middle? So let's say I want to remove this node. Okay, how would I accomplish this? In order to remove this node, so let's say they give us index here. Let's indicize them: 0, 1, 2, 3, and 4. Let's say I want to remove the second index. So if I get to the second index, so I can go, the first node, and then I can go to the second node, then I can go to the third node. Once I'm at the third node, how can I remove it? Right, you can't really remove it. Like, you see, if I'm at the third node and I want to remove the fourth node, by using the next variable of the third, I can remove the fourth. I can just make the next variable of the third null. Then it's not pointing to the fourth anymore. So everything after is gone. Right? That's the problem. You got to pay attention to that. But here we want to move third. So in order for me to remove third, I actually need the one before it. Because you can't directly remove a nodes from a list from the node itself. You have to go to the node before it and then change the pointer. So instead of it pointing to the third, I can make it point to the fourth. And now nothing points to the third anymore, therefore the third is gone. Okay, so the first thing we have to do is get to the node before it. How do we do that? So we can just do int current index. This is to hold our position, right? So we know where we're at. Are we at the first indice, the second indice, the third indice? Now, why do we need this? Because remember, the person passes us an index. So we have to remove it per index. Like, it doesn't tell us first node, second node, third node. It tells us by indices. So we're gonna hold our current index at 0, which is also the first node. And remember what we said? We can't change the first node variable. Like, we can't change the actual first node variable because that will lose the whole list. So we have to make a temporary variable, and we're gonna call it current node equals first node. I feel like I made a typo somewhere. There it is. Okay. So now what I'm saying is I'm holding the current node, which starts, remember, the current index is 0, and my current node is also the first node, which is technically index 0. Now I'm going to say while. While the current index does not equal the index you gave me, then go to the next node, because now I'm not at the node I'm trying to remove. But remember, this will exit the while loop once we are at the node we're trying to remove. But we said you don't remove a node from being at that node. You remove a node from being at the node before it. So what we need, we don't need the index, we need the index minus 1, because we want the one before it. Right, so minus 1. And now we open the bracket, and what do we want to do now? Is the current index, if the current index does not equal the index we want, then go to the next one. So current node equals current node dot next. So you see we're gonna move to the next one. And then, or you can, if it's easier for you to read actually, then what you could say is start a new variable e, make the next node equals current node dot next, and then I'm gonna say current node now equals the next node because I want to move on to the next node. And now I'm gonna say current index plus plus, right? Because I just moved to the next node, therefore I'm gonna increment my current index as well. And so you see this will keep looping, and every time it loops, it will increment my current index, and I'm going to move to the next node until my current index is equal to the index I want to remove minus 1, which is the one before the index I want to remove. All right, so now currently I am at the node before the one I want to remove. So what do I have to do? Back to visualization. Now I am here. Right, now I'm at this position. How do I remove the third? I have to first get the one I want to remove, see what it's pointing to, and make this point to it. Right? So how do I do that? Let's see. Let's create a new variable, node to remove. This is going to be the node to remove equals. I know that the current node is the node before the one I want to remove. So if I say node to remove equals current node dot next, that would be the node I want to remove. Okay, so now so right now I got the node I want to remove. Now how do I make the current node, which is 2, point to the node after the node I want to remove? It's very simple, don't complicate it. Current node, right? Dot next, so I want the current node dot next to point to the node I want to remove dot next. So you see what I'm saying? The current node's next point equals the node to remove's next, which is aka the one after. And that's about it. After you do that, you want to do size minus minus. And you want to also return, don't forget that we are returning, here let me close this actually, there you go. So remember, we have to return the data of the node we're removing. So let's do that here. I forgot to do it here, so we're going to do second node equals first node dot next, and then first node equals, okay, so we're going to do, so second node is the node we removed. Or sorry, the first node is the node we removed. So we're going to have to hold the variable here before, oh, never mind. this is when index is 0. So we actually return null. Remember, when index is 0, there is no next node data you want to return. You just make it null, right? And so here, what we want to return is the node to remove, right? Node to remove dot data, because we want to return the data of the node we just removed. And so that will return it. So when you remove a node, you will remove the node and also get back the data of that node you removed, just in case the user wants to use it before they, completely get rid of it. Okay? Now the next one is going to be insert. And this is the last one I'm going to do because these are really the most important ones. Once you get these, you can easily do the get and the set and all those other ones. So public void insert. Remember, for the insert, we're not returning anything. So what are we going to take? What are the two arguments? One, we're going to take the index, which is where we're trying to insert. And the second thing is the data. Because remember, we create a new node and we place it into that index they want us to place it at. Okay? So when we're trying index, let's clean this out and use the same example. There you go. Let's say I am trying to, so let's create a new node, and the node is going to be 10, and I want this node to be in place, to be at the second index, okay, to index number 2. That means the 3 will shift to the right, become index 3, 4 will shift to the right, become index 4, 5 will shift to the right, become index 5, 10 will become index 2. Okay, that's what we're trying to do. Now I'm going to remove this arrow because I don't want to confuse you, because this, when you first create it, this will point to null. Okay, so first let's create our node. We're going to say node e equals node to insert equals new node, and then we want this to be e data. Right? This is the data they passed us, so we're going to create a new node with that data. Okay, now that we created a new node with that data, what if they give us an index if the index they give us is less than 0, right? Because we can't place it at a negative index. Or the index they give us is more than size. Now pay attention, this is not more than or equal to size, because here size, you see 1, 2, 3, 4, 5. So here size equals 5 and index equals 4. Now if they give us a index that's equal to the size, that just means add a node after the last one, right? Like, which is completely fine. But if it's more than the size, it's not equal. If it's more than the size, they're telling us add it not on the 5th index, which is right after, which is fine. They're telling us make the 5th index null and then add the 6th, add a 6th index, which kind of like doesn't make sense. You can only add them one after the other. You can't have a null node and then have a node after it. It doesn't work that way. So if the index is more than the size, then return. Don't do anything, because you can't add a negative index and you can't add an index while you have like a gap in between. But if you give us an index that's equal to the size, then we'll just add it to the end. Okay? So I hope that clarifies things. Okay, so now the next step is, what if they're trying to add an index 0? So let's say they're trying to add, so the first scenario we're going to go through is, what if they want to add it right at the beginning? What do you have to do? The first thing you do, you can't make the variable, remember the variable first node, I can't make the first node equal the new node. Right? The reason for that is because if I do this, I lose all of these, which is not good. So what I have to do is first make the new node point to the first node, then make the first node the new node. Okay, so I hope that explains it. I'm going to say it one more time. Remember, this is null. I want the new node to point to the first node, then I want the variable first node to become the new node. Okay? So, First, we want, like we said, we want the new, so node to insert, dot next, we want it to point. The reason I do dot next, because what I'm saying is make the next variable of the node to insert. Remember, this node has a next variable. So when I do dot next, I'm calling the next variable of the new node. Okay? I want it to equal first node. So now the new node points to the first node. Now the next thing I want to do is have the first node become the node to insert and return. Before you return, you have to do size plus because we just added one. Okay, so now as you can see, the node points to the first node, then the variable first node becomes the new node because the new node now is at the front. Okay, so now that that's done, we're gonna do insert in the middle. So let's clean this gibberish one more time. Okay, no, I'll just delete the whole thing. Okay, so now I am going to create a node called 10 that currently points to null. I want it to replace the second indice. Remember what we said, when you're at a node, you can't manipulate the node itself. You can either manipulate its data, or you can manipulate what it's pointing to. So if I want to place this here, I can't be at the node I want to replace and replace this. I have to be at the node before it and then make it point to this. But if I make it point to this first, then I lose it after. So before I do that, I will go to this, to the node before the one I want to replace, then make the new node point to the node after it, then make this point to it. Because you see, if I okay, that's an ugly circle, but if I make the new node point to 3, nothing happened yet. Like, everything's fine. But if I don't do this part and I make this point, I lose everything after. So first, I make a point, which is fine, nothing happened. Then when I make this point and I cut ties here, that's fine, because now you see this connects to this and this connects to this and it keeps going. Okay? So we're going to do just that. The first thing is we have to obviously go to the indice before the node. So we have to go to the node before the node we're trying to insert into. Okay? So again, just like earlier, we want a current index equals 0. We're going to start at the beginning. Then remember, we can't make the first node move places because we lose everything. So again, we're going to have to create a temporary variable. We're going to make node e current node. This is the node we're currently at. Equals the first node because we're going to start at the beginning. Then I'm going to do while. While what? Okay, so here what we're going to do is current node while the current node, oh whoops, I made a mistake, while the current index does not equal the index minus 1. Remember, I'm not trying to be at the index I'm trying to replace or trying to insert into. I'm trying to be at the index before it, because that's where I can kind of control things. I can't control things at the index I'm trying to insert into. Alright? So that's why we're trying to go to the one before it. And so if the current index does not equal the index I want, go current node, go to the next node. So actually I'm going to write this, I'm going to write an extra line so I can explain to you guys. This is going to be next node equals current node dot next. Oops. There you go. And then what I'm going to say is current node equals next node. So now I'm going to move to the next node. Now I'm going to say current index plus plus because we just moved the node. Oh my god, plus plus. Okay, so you see now this will keep looping until the current index becomes not the index I want, but the index before it because of the minus 1. Then it will exit. Now when that happens, what do I know? I know that the current node is the node that points to the next one. So is the node before the one I'm trying to insert into. But remember, again, before I can replace the current node, before I can replace this arrow, before I can do that, I have to first make sure the new node points to the to this node, because if I don't and I replace this, I will lose all that. Okay, so this is what I'm gonna do. I'm gonna say node to insert dot next equals. I want it to point where now? I want it point to the current node, because remember now the current node points to the one I'm trying to replace or like push to the side. So equals dot next. So here what I'm saying, I am saying that the node to insert, which is the new node, I'm going for the next variable. Okay, actually, let's clean this out first. Boom. Okay, let's remove these. No, let's remove all that. Okay, I'll use green this time. Okay, so what I'm saying is, as you can see, line 71 right here, I am saying node to insert dot next. So I'm saying the next variable of this node equals the current node next. So whatever the next variable of the current node, I want it to be this variable. So what is the next variable of the current node? Of course, it's this one, because that's where it's pointing to. Therefore, if I do this equals this one, well, not this one, like the next, that means this one is pointing now to the third. I hope this makes it's very clear. All right. So now that the new node is in the right place, I can finally change the current node to point to the node to insert. See, now that I made sure the new node points there, now I'm going to change the current node to point to this one. And you see now this arrow is gone. So as you can see, now if I put the indices again, you have 0 stays 0, 1 stays 1. This is not 2 anymore, this is 2. This is 3, 4, and 5. Don't forget, don't give up just yet. You have to do sites plus plus, and you don't need to end it since it already has ended. So take a look at it for a little bit more. I hope everything makes sense so far. Okay, now we're gonna move to the next function. But before we move to the next function, what I'm gonna try to do is, actually before I do that, I just want to review, make sure everything I did is right. So we have node to insert dot next, current node. Okay, everything is good. Okay, now we're gonna create the list. So we're gonna create a main method. So public static void main string. You wanna start. This is kind of like standard of how you would start a main method. Now remember earlier at the beginning I said to start it, this is how you initialize your list. I want it of integer type. I want it called only potatoes, let's say. Actually, let's just go normal. Let me be normal for once. List equals new, because remember we're making a new instance of the list. Singly linked list, and now we created the list. Now let's add things to the list. List dot add. Right. So right now I'm calling this function up here, and I'm gonna pass it data. What do I want? Remember, I made it an integer, therefore I have to make it as an integer. Let's add 0, and then so this part, when I do list dot add 0, this tests this part of the code because the size is 0 at first, and I'm adding the first element. So this is the first part that gets tested. Then if I add another one, it will test the second part. So let's add another one so we can test the second part. List.add1. So this will add now. This will test the full add function. So if both of these work, that means the add function works perfectly fine. Okay, so we're gonna do system.out println list. Now you'll watch something happen here So first I'm going to compile my node, and then I'm going to compile my singly. Okay, so I have an issue here. Cannot find symbol, new node, current node. What line is this? Line 21. 20 here. It cannot find new node. What do we do? Oh, we initialize new node inside an if statement, which is not the right thing to do. So here we're going to say node, because either way we're going to have to initialize a new node, right? Oh, and why this is supposed to be data. So there you go. Because if it's the first one, then we will create the new node, and if it's not the first one, we're going to add it here. So that's why I initialized it outside, because we're going to use it either way. Okay, so let's see if we have any other errors here. Probably do. Okay. Line 51, new node, e-data, what do I do? Line 51. So let's go to 51. Okay. Here it is. Again, here this is supposed to be data. Little syntax errors, it's fine. It happens, it happens. Okay. Oh, you see, I've done it multiple times, which is a problem. Oh wait, I didn't save it. Whoops. Okay. Error, singly linked list, reached, I didn't close it. Little syntax issues. There you go. Okay, so cannot find symbol, current index. Did I really have? I think it's because, what line is this? This is line 65. I think it's here. So I have while current index. Oops, you see more little typos. Okay, what else? Is there other current index? Okay, that should fix it. Okay, Java C singly linked list. There you go. Now it runs. So now we're gonna run the file and see what it prints out. As you can see here, actually let's then singly Java. So this is our file, and then what we're gonna do is we're gonna run it here. So singly. As you can see what it printed. So out here, I did system out list and it printed this. Why is that? Because when you try to print a list, it's an object. So what Java will do is it will print you the object, and it will print you the memory address. Remember the RAM? This is where the list is stored in the RAM. So it will print you the address as well. So in Java, there's a built-in method called toString. So if I have here, I'm going to do an example. If I have int num equals 1, and I do num.toString, like this will turn my 1 into a string. Alright? But I can override this and make a custom string. So when I try to print my list, I'll print a custom string. So I'm going to do override public. I'm going to return a string. The method name is toString. It doesn't take any parameters. And then what I'm going to do here is return a custom string. So I'm going to create a string variable result. And then I'm going to initialize it as an empty. Right? Then what I'm going to do, I'm going to say node current node equals first node. So right now I'm just initializing a temporary variable, just like we've done all the other time. Then I'm going to say while the current node dot next does not equal null. What does this tell us? If you remember from earlier, this will tell us that we're at the last node. Once we get to the last node, exit the while loop. So while we're not at the last node, what do you want us to do? I want us to have the result plus equal current node dot data. So you see what I'm doing here is I'm adding to the result whatever the data. So if the data is 5, then I'm going to add a string, like a 5 to this string. To this empty initialized string, I'm going to add 5. And then what I'll add is like a comma. So let's do that. Plus a comma. Alright, I'm trying to make it look like this basically. I'm trying to make the list look like let's say 5, 2, right? That's what I'm trying to do. So I'm going to initialize it first with an empty bracket and then add my information onto it. And then once I add it, I want to do current node equals current node dot next, which means move on to the next node now because we already took the data for this node, right? Now this will exit before adding the last node because the last node's next is null, so it never passes through. That's why down here we will do result plus equal the last current node, which is data, and then we will return result. But before I return result, I want to add to it the closing bracket. Now, if you want cleaner code, I guess we could always do it up here, right? So I can do plus the closing bracket, and that's about it. Whoops. There you go. And we'll add a little more space. Okay. So now I can go here, Java C. I'm just compiling right now. Oops, result is missing a semicolon. There you go, so it compiled. So now I am gonna run it, and as you can see, this is the 1 and 0 we added. Let's delete the space here. Okay, so let's test out the remove. So we're gonna remove it. So first we're gonna remove index 5, which doesn't exist, which shouldn't do anything. So let's take this line. Let's take this line and place it under here and run this again. So compile and run it. See, nothing happens, no errors. The program works just fine because we handled that if the index is outside, don't do anything. Now, list.remove. Let's remove the first index, which is 0. So actually, before that, I feel like this is going to get a little bit confusing, indexes and numbers. So I'm going to make these numbers that kind of stand out more. So like, let's say 15 and 20. Okay, so now I'll do list. Oops, what's going on? Okay, so I'm going to do list.remove the first index. So now the 20 should disappear, right? So let's copy this, paste it here, and again, compile, run it. As you can see, the 20 did disappear. Now again, let's do list.insert at the beginning. So we're going to say at the beginning, and then I want to insert 25. And I'll do list.insert also at the end. So what's my list right now? We added 1, we added 2, then we removed, so index 0, index 1, then we removed, so now it returned to index 0, then we add 1, so now it's index 1, then we're going to remove index, we're going to insert at the beginning. Well, actually, the one above we insert at the beginning, so let's insert that 1, 30, and there you go. So as you can see, first is 15, that's after we remove. Then we insert at the beginning 25. Then we insert 30 at index 1. So you see that the 15 got pushed to the right. But if you guys, here, actually I'll paste this in here so you see it step by step. As you can see, first we inserted the 15. Then we inserted the 30 in the middle between the 25 and the 15. Now what if I want to have it after the 15? So let's do that. List.insert, we'll do, what is it, 0, 1, 2, 3, index 3, and we're going to add 45. And then again, paste this. Let's see how that turns out. Whoops. Java C, and then Java. As you can see, 45 got added after the 15. And so that is really all there is to it, to linked lists. If you guys have any questions, do comment. If you want me to cover other things, do comment. I'm not covering the get, and What else is there? I'm not sure what else is there, but I'm pretty sure these are the hardest ones. So if you do get these, then you should be able to do all the other ones. Hope you guys found this video helpful, and I'll see you next lecture. Now I gotta take my slow ass mouse all the way up top.